Professor Hawking, in the very last paragraph of your book, you say that if we discover a complete theory of the universe, then it should in time be understandable in broad principle to everyone and not just to a few scientists. And when that happens, all of us will be able to start discussing the why rather than the how. And I quote, "If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God." Do you think that God can intervene in the universe as he wants, or is God too bound by the laws of science?
The question of whether God is bound by the laws of science is a bit like the question, can God make a stone that is so heavy that he cannot lift it? I don't think it is very useful to speculate on what God might or might not be able to do. Rather, we should examine what he actually does with the universe we live in. All our observations suggest that it operates according to well-defined laws. These laws may have been ordained by God, but it seems that he does not intervene in the universe to break the laws, at least, not once he had set the universe going. Can you hear me? I am delighted and honored to receive a special prize in fundamental physics. I would like to thank Yuri Milner for founding these prizes, to recognize outstanding work that may not qualify for the Nobel Prize, because it is very difficult or impossible to confirm experimentally. In my case, although almost every theoretical physicist agrees with my prediction that a black hole should glow like a hot body, it would be very difficult to verify experimentally. The temperature of a macroscopic black hole is so low. I thought my discovery would never be confirmed or recognized. However, it could be claimed that it has already been indirectly confirmed by observations of the microwave background. It is thought that the very early universe underwent a period of accelerating or inflationary expansion. This would create conditions similar to a black hole, and would give the universe an effective temperature. Thermal fluctuations in the very early universe would be frozen in, and would cause small differences in the microwave background in different directions. These have been observed, and agree with predictions. The thermal emission from black holes is important, because it shows that black holes have intrinsic entropy, and it shows that there is a deep connection between gravity and thermodynamics. It plays a key role in the ADS-CFT duality. I have also made contributions to cosmology. My early work with Roger Penrose showed that classical general relativity predicted the universe had a beginning in a Big Bang singularity. That the universe had a beginning in the Big Bang 13.7 billion years ago is now accepted by most people working in cosmology, and is supported by the discovery of a faint background of microwaves. The prediction of singularities indicates that classical general relativity breaks down and has to be replaced by a quantum theory of gravity. Jim Hartle and I proposed that the quantum state of the universe should be defined by a path integral over all compact Euclidean metrics without boundary. In other words, the boundary condition of the universe is that it has no boundary. The no boundary condition implies that the laws of physics hold everywhere, even at the beginning of the universe. Together with Thomas Hertog, Jim and I showed that the no-boundary proposal predicts that the universe began with a period of inflation, a prediction which may be confirmed tomorrow, when the data from the Planck satellite are published. I feel a sense of achievement that I have managed to make these contributions, despite having ALS. I have not allowed my disability to stop me doing most things. My motto is there are no boundaries. Thank you.